In this video, we're going to provide visual proof for the angle subtraction formulas for sine and cosine. The basic idea for this visual proof comes from another YouTube video that unfortunately I cannot find, and so I can't provide a reference to. I've tried to add some value to it, but nonetheless the original idea does come from that earlier YouTube video. All right, let's take a look at the proof. We will start by creating a rectangle, and then in that rectangle we will draw a line from the lower left-hand corner to the upper side of the rectangle. The angle that's created by this line and the base of the rectangle will be angle alpha, and then we draw a line perpendicular to angle alpha that intercepts with the right side of the rectangle. And then we'll draw a line from that point back to the lower left-hand corner of the rectangle, creating a right triangle. At this point, we have two right triangles that share a hypotenuse. And that's an important point to remember if you choose to reproduce this proof later for yourself. For that newly created right triangle, the angle on the left is marked as beta, and that means that the angle between the base of the new triangle and the base of the rectangle will be alpha minus beta. We then designate the shared hypotenuse of our two right triangles with the value 1, which will make our trigonometric values easier to determine. Now, since this angle in our bottom right triangle is alpha minus beta, the complementary angle must be 90 minus alpha minus beta. And because this angle in our second right triangle is beta, its complementary angle must be 90 minus beta. Therefore, the remaining angle must be 100 minus 90 minus alpha minus beta minus 90 minus beta. And if you distribute the minus signs through that expression, you'll find that that angle must in fact be alpha. And then, of course, its complementary angle would be 90 minus alpha, which means that this angle must also be alpha. And now that we've determined the angles in our diagram, we can determine the trigonometric values of each of the sides. So we'll start at the bottom and say that if this angle is alpha minus beta and the hypotenuse of this triangle is 1, this side must be cosine of alpha minus beta. And using similar logic, this side must be sine of alpha minus beta. Now, turning our attention to the internal right triangle, which also has a hypotenuse of 1, the side adjacent to our angle beta must be cosine beta, and the side opposite angle beta must be sine beta. Now we can use sine beta as the hypotenuse of this triangle to determine that the side adjacent to alpha must be cosine alpha times the hypotenuse of this right triangle, which is sine beta. And in a similar way, this side, which is opposite angle alpha, must be sine alpha times the hypotenuse for this triangle, which is to say sine alpha times sine beta. Now moving over to this triangle, we see that its hypotenuse is cosine beta, so the value of the adjacent side must be cosine alpha times cosine beta. And finally, the value of the opposite side must be sine alpha times cosine beta. Now, because we have a rectangle, we know that each of the facing sides must be the same length. So, for example, this right side is exactly the same length as the left side. And that leads us to the identity for sine alpha minus beta. Specifically, we'll set these lengths equal to one another and then subtract cos alpha sine beta from both sides, which yields that sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. And we can do the same thing for the upper and lower sides. And here we see that cos alpha minus beta is the same as sine alpha sine beta plus cos alpha cos beta. And those are our two subtractive angle identities for sine and cosine. I hope you enjoyed this visual proof, and thanks for watching.